compared to angle 54, x is opposite and 10 is adjacent. So I think about SOHCAHTOA, and the one with opposite and adjacent is going to be the TOA. So I'm going to choose TOA. I'm just writing that down as my formula for this question here. My statement that I write then is that tan of the angle 54 degrees is equal to opposite, which is x, over adjacent, which is 10. I could write that the other way around as well, backwards, that x over 10 is equal to tan 54. I might write it the backwards way. Now, I don't want 1/10 of x, I want the whole of x. So what I do next is I multiply both sides of this equation by 10. When I do, I see that x is equal to 10 times tan 54 degrees. So I stick that into the calculator. And the calculator says it's 13.76, and it doesn't say what to leave it in terms of a ratio. I'm just going to roughly maybe to one decimal place, so it would be 13.8, and it doesn't say if that's in centimeters or anything, so I just leave it as 13.8. And it doesn't say how to round it off, so I leave it at one decimal place. The next part of this question, just before I move on, does that seem okay? Do we understand what I did there?
Yeah.
And did you get this? Okay. So again, I'm going to do the same with the second part of this. Again, I might do it a little bit quicker each time. I label the sides. Compared to the 32, the x is opposite. And be careful, can someone tell me what is the 12? I would like someone to tell me that. What is this? Hypotenuse. Very good. They're trying to fool you with the question the way they've twisted it around, but I can see that it's across from the right angle. So 12 must be the hypotenuse. So I'm thinking the one with O and H in it. So that's so. So the rule I'm going to use this time is that I'm going to use sine of the angle. Again, writing it backwards, that opposite over hypotenuse, which is x over 12, would be equal to sine of the angle 32 degrees. But I don't want 1/12 of x, I want all of x. So if I multiply both sides by 12, I would see that x is equal to 12 sine 32 degrees. So again, I take out my calculator. Where's my calculator here? And I write in that 12 sine 32. And it tells me roughly it's 6.4 to one decimal place. I'll leave it at that, 6.4. Okay. Did we get that right last night?
Yeah.
Good.
Yeah.
And I'm going to quickly do each of these again, just that we have some examples and we have them here on video. So step 1, label sides. This is my opposite, this is my hypotenuse. I think which has O and H, and I go, well, that's so, has O and H in it. So I write out my sentence in maths that x over 7 is equal to sine of the angle 33 degrees. So x must be equal to 7 times sine 33 degrees. I take out my calculator and I write in that. I write in 7 sine 33 degrees. And it's telling me, it says to one decimal place this time, it's 3.8 to one decimal place. And it doesn't say if it's in centimeters or what units. I'll just have to leave it as 3.8. Again, label sides. Compared to 42, y is opposite and 15 is hypotenuse. Again, we're using sine here. So sine is the formula that I choose out of SOHCAHTOA. The statement is that the opposite, which is y, over hypotenuse 15 is equal to sine of the angle 42. So then y must be 15 times sine 42. Now again, I take out my calculator. 15 sine 42, the answer is 10 to one decimal place, 10.0 or 10. And the last one, again, labeling the sides. Compared to 58, this is opposite and this is hypotenuse. Again, we're using sine, so it just happened to be we're using sine in each of these. because that's the information that we were given. So my statement in this one would be that the opposite divided by the hypotenuse, which is z divided by 12, is equal to sine of the angle 58. So therefore z must be 12 times sine 58. So again, into the calculator I sub this in. Getting it right this time. And I'm getting 10.2 to 1 decimal place. Did anyone get those answers last night?
Yep.
Okay. So,
Yeah.
if the question is to find the side, that's how we do it. Okay. Unless you know two sides, in which case, if you know two sides, you wouldn't do that. How would you find the side in a triangle if you knew two sides already?
Pythagoras Theorem.
Good answer. So if we knew two sides in a right angle triangle to find the other, we use Pythagoras Theorem. But if we knew an angle and one side, we'd use that method. Now, the other question you could be asked here, as well as being asked to find a side, you might be asked in a question to find an angle. Here we've been asked to find the angle ACB. I think it's okay to call that angle C as well, so I'm just going to call this angle C. That's what I'm interested in finding. So that's my question. What is the size of angle C? Okay. How would I do it? Again, it's kind of done the very same way as before. The steps are the same. So step one, I'm going to label my sides. Step two, I'm going to choose SOHCAHTOA or TOA and write an equation. And step three, I'm going to solve the equation. Okay, so what does it look like? Compared to side C, what is this side 9? What would I call the 9 side?
Opposite.
Very good. So that's my opposite. What's the side with 13?
Adjacent.
Adjacent. So then I'm onto the second part. I've labeled the sides. Do I use SOHCAHTOA or TOA?
TOA.
TOA. The one with opposite O and A in it, I'm going to use tan. So I write my sentence. My sentence is that tan of the angle C is opposite, which is 9, over adjacent, which is 13. Now, we actually learned to do this on the calculator last week. Can anyone tell me what must C equal? If tan C is 9 over 13, can anyone remember what we used on the calculator to find the angle? What did I type into the calculator?
Tan inverse.
That's a really good answer. So on the calculator, what I write then is that tan inverse shift tan. So every time I'm finding an angle, I'm always going to use tan inverse. And I write what I see, tan inverse 9 over 13. Okay. So I'm going to write this here. So my statement is that tan C is tan inverse 9 over 13. And I type that into the calculator. And the calculator is in degrees. You have that little D in front of you. And I press equals. It says 34.69 degrees. It's asking you to tell me this to the nearest degree. So rounding off to the nearest degree, it's 35 degrees to the nearest degree. Okay. Again, what's one of the lessons here in the solve part of this? When you're solving it, when you're asked to find an angle, because that's what this question is. This is find an angle. The method looks very similar to as before, except one thing at the very end. You're always going to be using the inverse function to find the angle. You're always going to use the inverse to find the angle. Can I ask you to try a question that looks like this yourself then? Okay, so it looks like before. We're labeling the sides, choosing SOHCAHTOA or TOA, and we'll be using inverse of sine, cos, or tan to find the angle. So let's get a question that looks like that. Okay, so here it is. Okay, I would like you to look at question 4 here. This first one here. Can I ask you to find, in this triangle with sides of 3 and 5 as are given here, could you work out angle A for me, please, to the nearest degree? I'll give you 2 minutes to try that now.
Yeah.
Yeah, what is it?
Yeah.
What did you say?
36.
So to the nearest degree, 36 degrees, that's what we're getting?
Yeah, I got 37.
37?
Yeah, 37.
So maybe that's a rounding off issue, maybe? 37 degrees. Okay, so let's have a look at how you would have done this. It looks good. It looks that it probably is 37 degrees. Just one reason why I might be able to, why I think that looks good. Look, if this is 90 degrees, I know the two of these add up to 90 degrees. This seems to be the smaller side than the other, the adjacent side. 3 is smaller than the adjacent. So I'm thinking this should be a bigger angle. So looking at it at a glance, I suppose this angle must be greater than 45 degrees and this angle must be less than 45, but not too small. So at a glance, look, it looks like a reasonable answer, just to say that. So it's important to have a sense of the reasonableness of your answer. So let's label the sides. Compared to A, this is opposite, this is hypotenuse. I'm looking at SOHCAHTOA TOA and I'm thinking it's using opposite and hypotenuse. I'm going to use sine afterwards. So I would say sine of the angle A is equal to opposite, which is 3, over hypotenuse, which is 5. So then I say A is equal to sine inverse 3 over 5. And that's what I type into the calculator. And it's telling me it's 36.86, which is closer to 37. So I'm saying this rounds off as 37 degrees to the nearest